We're taking the limit as x goes to 5 of the expression shown. Well, looking at our denominator, we see that we have the cubed root of x plus 3 minus 2. And sometimes students think all they need to do is multiply by the cubed root of x plus 3 plus 2, but that doesn't work because we're taking the cubed root, not the square root. So we want to rationalize that denominator, but we're going to have to do it by something a little more complicated. We're going to have to recall how difference of cubes work. The difference of cubes states that a cubed minus b cubed is going to equal a minus b times a squared plus ab plus b squared. Well, what we're going to do is we're going to say that that denominator of the cubed root of x plus 3 minus 2 represents the a minus b. So in other words, what we're saying is we're letting a be the cubed root of x plus 3 and we're letting b equal 2. Well, that would mean that a squared was the cubed root of x plus 3 quantity squared. The cubed root of x plus 3 is the same as x plus 3 to the 1/3. Since we're squaring it, we get x plus 3 quantity to the 2/3. AB, which is the second term here, will be 2 times the cubed root of x plus 3. And finally, b squared will be 4. And so what we're going to do is introduce a factor of x plus 3 to the 2/3 plus 2 times x plus 3 to the 1/3 plus 4 to both the numerator and the denominator. And that's what we do. We multiply it, we introduce it to both the numerator and the denominator. Now, a little bit of a further explanation, which I won't go into verbally, is right here. But what ends up happening, what we can see, is that when we introduce that new factor to the denominator, and obviously to the numerator, but when we introduce it to the denominator, the cubed root of x plus 3 times x plus 3 to the 2/3 is x plus 3. Then when we do our expanding, we get the cubed root of x plus 3 times 2 times x plus 3 to the 1/3, which is plus 2 times x plus 3 to the exponent 2/3, plus 4 times x plus 3 to the exponent 1/3, minus 2 times x plus 3 to the exponent 2/3, minus 4 times x plus 3 to the exponent 1/3. And so they've all canceled out, and our last term is minus 8. And so what's happened is our new denominator is x plus 3 minus 8. Well, that simplifies to x minus 5 as shown in green in the next line, and our offending factor of x minus 5 is able to be crossed out of both numerator and denominator. From there, we simply have that numerator term of x plus 3 to the 2/3 plus 2 times x plus 3 to the 1/3 plus 4 remaining. And now we can simply substitute in the x value of 5. Doing that gives us 8 to the 2/3 plus 2 times 8 to the 1/3 plus 4. 4 plus 4 plus 4 equals 12, and that is our final answer. That's what the limit equals.